Welcome to the class. In this video, we'll see some questions, reflection on concept. So, question number 1 over here. Identify the element that has lower atomic radius or atomic size in each pair. So, pairs are given. You have to identify the element which is having lower atomic radius. So, for this, what we are supposed to do is you have to do a little bit of workout. What is that workout? Now you have to check these two elements whether they are in period or in group. So what is your magnesium and calcium? So before that, before going into these type of problem, it is better we write down elements like this. Okay, this hydrogen here, lithium, sodium, potassium, right? Then it comes here lithium, beryllium, then here boron, carbon, nitrogen, oxygen, fluorine, and neon. Same way sodium, it's magnesium over here, right? Aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Same manner, hydrogen, then you will come across helium here. So potassium, then calcium. Right? Scandium, titanium, vanadium, chromium, manganese goes on. Still to some extent, what? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So beryllium, magnesium, calcium, strontium, barium, and radium. Same way here, helium, neon, this is argon, then it is krypton, then it is xenon, and radon. Right? Like this, if you can write down to some extent, it will be easy for us to solve problems. Fluorine, chlorine, bromine, iodine, and astatine. Okay? Right, now let me start. In period, as you know very well, so let me work out atomic size. In period it decreases, and in group it increases. This much I know, because my problem is only problem. I have to solve atomic radius. Which one of these two is having lower atomic radius? So I need to remember this one. Right? What is it now? Magnesium and calcium. Where is magnesium and calcium? Here. Magnesium and calcium are here. So when you move like this, atomic size decreases. When you move down, atomic size increases. But the question is lower atomic size. Therefore, my answer is magnesium. Okay. Next, coming to cesium and lithium. Where is cesium and where is lithium? Lithium is here and cesium is here. Down the track in the group, when you move down, atomic size increases. But he is asking lower one. So the answer is lithium. Next, coming to nitrogen and phosphorus. So it's here, nitrogen and phosphorus are here. Okay, so they are again the group elements. They are elements in the group. So when you move down, atomic size increases. Therefore, is asking you lower. The question is lower. Therefore, it's nitrogen. The next one is magnesium and chlorine. Magnesium is here. Magnesium is here, and chlorine is here. Right. So these are P elements in the period. So in period, as we move from left to right, atomic size decreases. So he's asking lower one. So this is your answer. So in this way, you have to work out with this one. Okay, this type of question. Now coming to identify the element that has higher ionization energy. Higher ionization energy. Okay, so actually, what happens to with ionization energy? When you move in the period, it increases. When you move down the group, it decreases. So that much if you remember, the question is higher. So you have to write about higher. So you have to pick up elements which are in the period, right? So now, so here magnesium and sodium is given. So you have to rearrange them. They are actually sodium and magnesium. They are supposed to be sodium and magnesium, right? Good. So they are in the period, isn't it? So in period, as you move from left to right, atomic ionization energy increases. He is asking you higher only. So the answer is magnesium. Finish. Now these two, lithium and oxygen. Where is lithium? Here. Lithium is here and oxygen is here. So lithium and oxygen means we are speaking about what? They are in period. So in period, as you move from left to right, ionization energy increases, and moreover is asking you higher only. So the answer is oxygen. Okay. Now coming to bromine and fluorine. So bromine and fluorine is here and bromine is here. So 7A group elements, halogens there. So down the track, what happens? Ionization energy decreases. So when you speak about fluorine and bromine, so when you move down, ionization energy decreases, therefore this is higher, fluorine is higher, because when you move down, atomic size increases, so ionization energy decreases, right? Ionization energy decreases, so he's asking you higher one. So fluorine, then comes bromine, so fluorine. Next one is potassium and bromine. So where is potassium? First of all, potassium is here. Where is bromine? It's here. So these two are in period. So in period, as you move from left to right, ionization energy increases. So your answer is bromine, right? We'll come across the next question. Get ready for the next question. Now let's discuss about the third question and fourth question. Third question says that name two elements. Okay, name two elements that would expect to have chemical properties similar to magnesium. How? What do you understand? Tell me. He's asking you to give two more elements, not two more. You can give remaining four elements also, 4 to 5 elements. Okay, if you can expect to have chemical properties similar to magnesium, properties, the elements which are in the group will have same physical and chemical properties. That is already a caption. It is given under the periodic table. The elements are arranged in the groups according to their physical and chemical properties similarity. Therefore, he is nothing but he is speaking about simply second A group elements, because you find magnesium here. So the other elements are what? Beryllium, magnesium, calcium, strontium, barium, and radium. These are the other elements. So he has given magnesium. So other any two you can write from the others. It is nothing but second A group elements. He is speaking about second A group elements, because where do you find magnesium? Second A group. So other elements will have similar physical and chemical properties. Finish. Next. An element has atomic number 19. Where would you expect this element in the periodic table? This is a super interesting question. When an element with some atomic number is given, what you're supposed to do you know? A very interesting thing it is. Given number is 19, isn't it? You split it into K shell, L shell, and M shell, like that. That is 2 comma 8 comma 8 comma 1. This is K shell, L shell, M shell, and N shell. Or else it is N is equal to 1, N is equal to 2, N is equal to 3, and N is equal to 4. Simple, right? So where would you expect? It is in 1, 2, 3, and 4. Therefore it is in fourth period. Fourth period. This is nothing but fourth period. N value. Fourth period. N is equal to, so N is equal to 1. This is N is equal to 2. This is N is equal to 3. This is N is equal to 4. This is N is equal to 5, 6, and 7. Moreover, you can simply split them. You will come to know. And what else you got here? 4, isn't it? You got it here. Here as 4. So 4 means it is fourth period. Clear, confirm. Other thing is what? 1 piece, 2 piece, 3 piece, and 4 piece. So it will be fourth period. Now how to identify group? Group is very simple. 1 here, 1. Last one is 1. Therefore it's first day. First day. Or IUPAC number is 1. How can you say it is in first day? Yes, because their valency is 1. Their charge is 1. Okay, simple. Right? It's nothing but which element do you think? It is potassium. Potassium, then comes calcium. So 19. So 4, see 4, fourth period. Okay, and see first day group element. It is first day group element. Easy to identify. Now let's discuss with the problem 5. Using the periodic table, okay, predict the formula. You have to predict the formula of the compound formed between the elements X. X belongs to group 13, it seems. X is belonging to group 13. Okay, done. X is belonging to 13 and Y is belonging to group 16. So we have to predict the formula. Very easy. It's very easy. You simply split this into 2 comma 8 comma 3. Therefore, X valency or charge is 3 plus. Finish. Because you remember, if it is 1, it is plus 1. This is first one. This is plus 1. This is plus 2. And the third, this group is plus 3. Isn't it? Charge plus 3. So all these are cations. So this is a cation because it's having 3. To make this 3 into 8, it requires 5. It doesn't take 5. It is ready to lose this 3. Therefore, it's ready to lose. Loss of electron. It gains positive charge. Now coming to this one, group 16, 2 comma 8 comma 6. Yeah, it's very close to 8. It can take 2. So why it is ready to take 2. So crisscross x, this 2 is given here and this 3 is given to y, crisscross, right? This is a formula of this compound. We finished the question. Now let us answer the question number 6. See, an element X belongs to third period and group 2 of the periodic table. So these are the 3 questions we are supposed to answer. But what about element? An element X belonging to third period. So when you take third period, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, till argon, they are third period elements. Sodium, it starts with sodium, ends up with argon. So now which element it is? It can be sodium, it can be magnesium, it can be aluminum, it can be silicon, phosphorus, and so on. But clearly he said that it is second group element, second group. Second group means IUPAC number. This is nothing but second A, nothing but second A. So third period second group element, third period second group element will be magnesium. So I identified the element. Okay, I identified the element. The element is magnesium. Answer. Finish. Now what is the first question? The number of valence electrons which are in the outermost orbit, they are called valence electrons. So magnesium atomic number is 12. Therefore it is 2 comma 8 comma 2. So valency electrons, first question, valency electrons are 2. Finish. Then question number B, valency is how much? Since it is 2, it is plus 2 is the valency, plus 2 is the valency. Now see whether it is a metal or non-metal. It is clearly, I told you in the previous videos also, all that are present on the left side, most of them are metals. So this is a metal. So we finished the answer for question number 6. Next. The next question is a very important question. I have mentioned it here. Very important. Okay. Right. In period 2. So one thing is clear that he is speaking about period 2 element. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So in period 2, element X. So he is not mentioning which element it is. Okay, done. X is to the right of element Y. Right? So he is telling that in period 2, he is not giving you the element, but period 2, a element X, just to take an element like X, it is right to element Y. That way fixed one is which one? Can you tell me which element is fixed one? Y. Y is fixed. X is coming and occupying right side of the Y. Okay. Alright. Then find which of the element have low nuclear charge, low atomic size, high electron negativity, high ionization energy, high electron negativity. First of all, you should know one thing. Element answer. Okay. When you answer, you should have a clear idea that which is the element already existing. It is Y. Y is existing. Y, now in which shape it is? See, if you take Y, Y is facing you. Suppose I am Y, I am facing you. If I face you, for me right is this side. This is right. Okay, for me right is this side, and you are facing me. You are in front of me, and you are looking at me. You are looking at me. For you, which side is right? This side for you, because you are looking at me. Okay, for me right is this side. Therefore this confusion is there. Very important. That's why this question is very important. You should feel that Y is like you. Y is sitting like you. Okay, so you are facing me, isn't it? So I'll turn and give you your posture. Same, you are like this, you are sitting like this. So for you this is right, isn't it? Therefore X is this side. That much only. If you can understand this, it's over, right? Y is like you, facing this side. So you're facing the board, isn't it? So Y is like you, facing the board. So X is an element which is right of Y. So Y is facing the board. Y is looking into the board. So X is this side. Finish. Now low nuclear charge. Remember atomic size, if you go this side it decreases. Okay, so if atomic size decreases, nuclear charge is more. Atomic size is little, nuclear charge is powerful. Why? Because nucleus can simply pull the electron towards its center because it is within its area. Therefore, he is asking you low nuclear charge. Then your answer for the first answer will be Y. Why? Because as you move that side, atomic size is decreasing. Size decreases means nuclear charge is more here. But he is asking you low nuclear charge, so your answer is Y. First one is over. Second, low atomic size. Now low atomic size will be X. Why? So as you move towards right side of the periodic table, atomic size is decreasing. Low atomic size, decreasing atomic size is this side. Therefore X, because X is that side. Finish. High ionization energy. Since atomic size decreases, everybody knows that ionization energy is increasing. And he is asking you high ionization energy only. So your answer is X. Then high electronegativity. I told you, no, previous videos, so many videos I told you. Ionization energy, electronegativity, electron gain, enthalpy, right? All these are friends, right? So you said that ionization, high ionization energy X means your high electronegativity will also be X. So one more is given, isn't it? More metallic characteristic. You remember metals in the periodic table, most of them are on the left side. Okay, so more metallic character means if you go that side, metallic character will decrease. If you go that side, decrease. This side it is more. Therefore, your answer, last and final answer is Y. Right. All answers are answered.